Namaskar. Let me give my sincere thanks to the four faculty member, particularly Dr. Richa Chopra ji, Madam, inviting me for this in front of the gathering, a chance to speak in front of you in the domain of architecture. The mid 90s, from that time it was as a, now it is NIT Calicut. I did architectural engineering over there, and fortunately, head of the department, Professor T.S. Balgopal Prabhu, taught us one subject which was not a in curriculum, but by our some likings and some likings to the actually the faculty. May not be that time we know what is that. So used to go to the evening classes of Professor Balgopal sir, and that course was the principles of Vastu Shastra. Mostly those classes was happen in Malayalam because he was speaking to the people, local people who are the students who are Malayali students. But some of our non-Malayalis are also somewhere in the backbencher. We see, we listen. Sometimes we listen for half an hour. Sometimes we listen for whole 1 hour lecture or so, evening lecture. So by virtue of that time, when I was almost about 21 years of age or so, I started thinking that there are some connectivity which is modern architecture and the ancient system of our forefathers who has actually built some of the rhythmic kind of the dimension and the applicability in the field. And from that point of view, I had a liking on that particular subject. And then what happened afterwards, I went to job and I went for my further educations, and all those were uh, went to the backdrop probably. But after coming back to IIT KGP, I was entered into this IIT KGP in 2011, almost 11 years, and then I was landed in a department where Professor Joyshin was there, and then he also knows Professor Balgopal, and gradually by some chai ka adda and all that things comes to again revive in our mind and all, and then last couple of years back we started this ICAS and this particular course what Professor Joshin already told you. Vastu Nirman Vidya course was floated, and it was very popular. It was very popular maybe because of 2 3 reasons, but one thing is that some students are very serious. 557 students what we are taking this time now. I must not say that all 557 students are very serious and all, but at least 130 students are very serious in this when they are actually submitting some kind of the term paper or anything. Before submitting the term paper, they take our time and discuss with us and all those kind of things. Just to see those kind of parameter, around 130 students are very serious. That is enough at this particular time in a land like IIT Kharagpur, where it is all kind of a technicality. 130 students in a batch is very serious about the course like Nirman Vidya, Asasastra and the Vastu Vidya. So let us start my presentation. My presentation will be on the particularly the applicability of the Vastu. Vastu, when I see, it's something like a planning dimension, the designing dimension. So after the planning, uh, I need a house plan, so I definitely contact a Vastu with the Sapati, and then that particular building plan has to be erected. They erected, and that is the Nirman. Then this particular Shastra, which is the Nirman Vidya, will came into the, that is something like a civil and the architecture. The architecture is called about the Vastu, who is going to having some kind of n number of principles, but based on that, it has to be designed, and finally, it has to be actually erected or it's a Sthapana. So you have to be Nirman. So from that point of view, we can be see the principles and the thinkers what way and the schools how gradually it was evolved. So whenever we go into any kind of the, so one point is very much clear is that This Vastu and Nirman has to go hand by hand. It both should be a conjugate. And we have to rely on what are the material is available with us, what are the different element we have to actually going to erect, what are the proportion of that Vastuvid has been actually imagined in form and composition and all. So in this whole domain, if I go gradually, these three component will be come into the picture. The one is the construction technology. It has evolved in the ages. If you start from the Vedic era to the Mauryan era to the Gupta period, and then gradually if you see, it has been evolved in various forms based on the material and the processes and the applicability and the engineering and also the management. A temple architecture is mostly a construction management. It's nothing else. The pyramid of Giza, it is a construction management. It's nothing like a kind of a more of architecture. It's mostly of a construction management. Then we need to see the building science of it. Yes, our forefathers are also used the material. They have actually acquired the kind of the power of a material from the climatology or the climate point of view. So we have to evolve in the thermal comfort point of view, the daylight and all other things. Finally, the structural systems. Whenever people build a building, it may be a mud, it may be wooden, it may be a stone, it may be brick, maybe anything else. We have to actually consider how the load has to be gradually from the shikharas to finally trickle down to the foundation and then to the soil. So that kind of a system, and it's a big temple, so there is a big huge number of footfall, so you have to take care of the crowd, so you have to having a larger openings, so to larger openings how the stone can be the rest on that. So those comes all under the part of the structural systems. And what we see today, it's if you derive, it is just give some kind of a derivative of that, is lesson from the past. Of course, there are a lot of things we have imparted into it. There are some new materials which is actually came into the picture. They are questionable. The things are questionable because nowadays, recently, in recent times, around 10 years or so, we are talking about the carbon free and all. We are talking about the sustainability and all. Because we have hampered in last 150 years or so. So after the industrial revolutions, we exploit the things such a way. Of course, there is a population pressure and all. But due to that, there was a suddenly need of the again go back to the future. And the future is, go back to the past, sorry. And this future will be actually, what I feel is that is actually going to evolve with the whatever we have generated in our past. Of course, Government of India is always recently initiated and some of the good schemes that what Professor Joyson has just now told. We are in a middle phase of implementing the bamboo as a building materials in this area where northeast and this part of the Bengal part and maybe the Odisha, where bamboo is very, very available. So how can we use bamboo for the materials or so that we are doing it. So I have just now told that is the material, it has a process, it has the application. With this particular triangle, we have to actually go with the engineering and management. But what I will actually going to deal with today, is this 4 segment of Indian knowledge system in the construction practice, the Nirman. And these 4 are the applicable area. Probably I can think this as a kind of a thought area, or the thinkers that actually give us in a particular way. One is the material sensitive construction, how they actually use the material and use it for the construction, and the best material is used for the best purpose. That is the sustainability. Next one is a structure sensitive construction, that when I evolve, I need a new type of building to construct, or any kind of the object to construct. I have to think that how this structure can be held. climate sensitive, it is always there. When the human being actually enter into a cave, the home is a cave. It is a climate sensitive, particularly climate sensitive, and also from the protection from the wild animals. So that kind of this is the very first, I should write it actually maybe the first, but this is the very first one. And last one is the activity sensitive. That we will also see how activity change the design pattern and the construction pattern. So these are the typical parameter that in modern times we say that what is the density of the material, what is the strength, tensile strength, what is this and that. And these are actually taken care of in domain, and we will see that this will be actually the strength and ductility will be in a, they have used for the structure sensitive areas where there is a the span, there is a huge amount of loading and all. This porosity, water absorptions, those are actually they import into the durability, life cycle materials and those kind of a maintenance point of view. The density and the hardness, if you see all the temple architecture, the carvings and all, so they have chosen those kind of stones from the density and the hardness point of view. From the point of view of the decorative features and also the time of construction, the total project time, manpower requirement and all those kind of things. The thermal expansion, the thermal conductivity, etc. has taken care of the climate sensitive part, and those are the indoor acoustical quality, which also imported in some of the palaces of, if you see in the Rajputana, I mean the Rajasthans and all, they have also imparted those kind of the properties, they have influence of those properties. So in the Vedic period, if you see, in nutshell, if you see in that particular era, the quality of the housing is the measure of the development. It was since then that we have actually imported in the quality of housing is a measure of the development. And there are a lot of Vedas, and particularly the Atharva Vedas, which actually given some kind of, in between I must say that I am still a learner, and this is a huge subject. And the one biggest, I may say this, the lack of in me is that I do not know Sanskrit, because by my virtue of my education do not allow me to learn that particular subject. Where I was, I mean, in my school days or so, there was no option to take that particular subject. So that is one of the biggest difficulty. But hopefully, with the things I am still learning, still see what are the things are taken there, and that can be brought forward. So those are the signs, the Sthapatta Kala and all. So those are still was there. Now if I see this particular, the housing character of the the early Vedic period, basically it was started with a circular manner. The circular manner is that, why? Because circle is one of the geometrical form which can be actually placed in the site very easily. It's very difficult to actually create a square in a land, because a square and rhombus both are having all four edges equal, but square has equal diagonal and they are perfectly 90 degree. So keeping that, I may actually, when I go for any building layout, its square may become a rhombus. I may not find it. I mean, it may look like a square, but there is a 1 inch some problem, and it may be deformed as a rhombus. But in case, I mean, the circle is the easiest one. You need a nail or something like that and a thread, and then this will be definitely a perfect circle. So they started with a circle, and using that particular circle, they gradually built they gradually go for the formation of the square. It is very easy to draw in AutoCAD or any software, or maybe in my drawing sheet a circle or so, or maybe a square or whatever, rectangle. It is very difficult in the ground, very difficult in the ground. And the ground is always not flat, ground is always not a very leveled or so. It may be with kitcher, makra and this and that, lot of stones and also where it is measuring circle, sorry, the square and all those things is very difficult. So that was the first. They start with a circular and plan, and circular plan with a conical shape with a thatched bamboos and all, and then gradually they go for this kind of the shape modification. So circle has some, of course, some kind of that disadvantage also from the internal point of view. So if you not only the India, if you go to anywhere, you go to African the civilizations and all, they started with a circle and then gradually compartmentalize the circle in a different room form and so on. The in the central portion is their kitchen or something like that. So in India also it was gradually formed like that, and gradually it has come down to a this kind of a shape, that's square and the rectangle and the deep rectangle. And by virtue of this, there was over the times this kind of changes instead of the conical or spherical roof, conical to spherical roof. Spherical, when it is come to a particular rectangular shape, it has extended, so it's making a kind of a cylindrical kind of a roof. And this cylindrical kind of a roof, when it was developed, you can see it can be one of the creation of that particular the Buddhist architecture where there is a Chaitya and all those things has been formed. So gradually it was developed like this. Building materials point of view also, they mostly used mud and ribs or this kind of the wooden things. Both are very climate the energy sensitive. Probably that time they do not know that kind of energy problem and all, but and maybe they do not know what is concrete and what is reinforcement and what is plastic and all, but still with the mud, and still people are using mud and all those kind of things, and it is very good material. Of course, with the mud I cannot construct a high-rise building, definitely so, but in a particular kind of arena we can actually still exploit the mud. Mud only requires some kind of a stabilization. Those days they use sand, lime and sand, dry leaf, husk of paddy as a stabilizer. And they also use the plastering material also. If you see, I mean that actually changes. Suppose in Vedic period there is a kind of a people are living in a particular society. The king of the society, not king, the mukhiya of the society, and their houses or maybe that particular what can I say, that where they actually come and discuss and all, that particular structure sometimes have the kind of the plaster, that kind of plaster, and plaster was found to be as a the gypsum and those kind of a plaster was that type time it was used. Also they have used some kind of the earthen blocks which is much more stabilized, and they have used this kind of the trifala as one of the type of the additive that can be give a particular better bonding and all those kind of things. It was transferred in the later period, which is more or less when it is going to be the Mauryan period. The timber came into the play. Timber came into the play. When there is a timber came into the play, the carpentry has been evolved, and due to the carpentry of the evolve and the timber came into the play, language of architecture is also going to change. See, whenever there is any new material will come, it is the construction people will recommend the material, and then probably the architect will start thinking how can I best use that particular material for any purpose. So the language of architecture change. Suddenly they can think of using timber, I can go little higher in level, I can have 2 floors or maybe multi floors kind of a thing. And then there is something like a kind of a society, or now a big society, and the kingdom is coming to the picture, so they need some kind of a secure kind of the arrangement, so they go for some kind of a bastion, gates and all those kind of a structure which is much more required much more stronger material. So instead of mud, they believe in stone and timber. There are some, so this particular effect of the material still we can see some of the vernacular architecture. The vernacular architecture means the architecture which doesn't be, I mean, it's generation after generation that is flowing. No, no one which is having kind of a degree of architecture or maybe a scientific knowledge of architecture is going to import or do a particular hut which maybe my forefather has been constructed. Now I have having some problems, so I made a something change. My son or my grandson has another set of changes or so. So gradually that particular dhara, that particular the dhara of the architecture is called the vernacular architecture, where no scientific things has been imported. Probably we went to the villages, we went to the those areas of where the so-called people are living, and we put some measurement and see, yes, this is very good, this is very good, like that we did. But there is no such of kind of scientific, as such scientific intervention. They are much more climate friendly and material friendly. The next, let us see some of the features of the structure sensitive construction. This is another very interesting area. So we started watching that particular event occurring, structure sensitive things from the Mauryan period, where again I must say it is the stone and the wooden things has been infused together, and houses and cities and gradually try to build. And when it is actually from the small the societal formation break into the urban formations or so on, the structure has to be important. As we always see in today's also, we see high-rise building in the urban areas. We do not see the high-rise building in the rural areas. So where there is a society is now clubbing together and making kind of a city or something like that, to enhance the resource, we have to think of some kind of the structure sensitive material, and that kind of thinking probably came in the Mauryan period, where they used to exploit that. So the one of the things that was first of all developed is the pillars and the sculptures and all, which required stone. And again I have, if I go back to my second or third slide, stone means which stone. They need to know the some hardness property of the density property of the stone. So if you take two different type of igneous stone and the laterite stone or something, laterite may not give you that kind of the benefit. It is very much brittle kind of a thing. Igneous stone may be very tough. So you may compromise with some sedimentary kind of a stone which is little soft, and that means your total number of manpower requirement will be less and your total time of construction will be also less. So within very nice time you can do some lot of decorative features also. So they used to do the capital, shaft, base, and they develop gradually. See, that will be something like that. This is a kind of a pillar which is three distinguished part: capital, shaft and base. It was everywhere, it was there. If you go to the Greek architecture, if you go to Roman architecture, they have different, and they develop. We say that was the Doric order, the Corinthian order, and those Ionic order, those three orders. These orders are initially the order of the capital and the base and the shaft, the proportion and all. It was developed. So in time of Ashoka and all, this was first initiated and then it was developed. So these are the capital. These are the capital is also maybe they have now then further distributed in different portions called some animal features, which is lion and all, and then the sitting of the lion, that is the abacus, inverted lotus and all those kind of things. The terracotta architecture came up, another new material invented, and the cave architecture was initiated in time of when the Buddhism has been flourishing and all. This is very interesting to me. At least I do not get those kind of the literature, but I was wooden architecture, as I told you, it was also very much prominent on that kind of area. So the wooden architecture is mostly important in that case, how the joineries has been made from the structure point of view. The cave architecture or rock cut architecture. So in the many part, the Bihar and the Madhya Pradesh, the Maharashtra, some part there are cave, the ample example of the cave architecture. So it was a cave and it was actually dig out and they created those kind of the shells like Chaita and the Biharas and all. Chaitas are the prayer room and the Biharas are the monastery kind of thing. Now you see this Chaita and Biharas and all. You see this is a cave architecture. So right hand side the Ajanta, this is particular a cave and a group of people dig the cave and created a particular void inside which is actually some shells. The dimension of the shells through the perimeter and to have this particular supporting arrangement they have those black peripheral columns. So interestingly that I do not know what is there, this is a cave, what is inside that, and I have some imagination I am just doing it. It is not the construction what we do today, it is additive construction. We do foundation first and then pillar, then the beam, then slab and then the walls and all. It's a kind of a piece of butter and then I taking out our piece of wax and I am taking out some kind of, and final formation is something like that. It is a reverse engineering. This is a reverse engineering and this engineering has a plenty of scope to know about the actual sense of engineering in that time. This, if you see this one, is again a Chaita and this you see they have how many 1, 2, 3, 4, 5, maybe 20, 25 pillars in a regular interval. The dimensions of the pillars are equal. The distance between pillar to pillars are almost equal. The edge leaving from the outer part of the hill or the cave and this is symmetrical. Absolutely amazing. If you tell me to do with stone in a additive nature it is difficult, it is reverse is much more difficult. So this engineering was actually evolved in our country and there are some examples of this kind of cave architecture also in the Egypt and also in some of the part of the West Asia, Jordan and all. So, but it is not that much elaborate. It is not that much elaborate. If you see the west coast of the Nile and the Egypt, it is something like a chamber kind of a thing and they put the mummy and all those kind of a thing over there. There are some temples which are little bit elaborated, but like this Buddhist architecture where the cave architecture was generated, it was just amazing. So this is the reverse engineering what we are very much expert on that those days. I also learned that today what we do is that we take a site, suppose I have a 30 meter by 50 meter site, I need a kind of a building. So as per the building bylaws, what I do, I leave some setback 5 feet, 5 feet, 10 feet, 10 feet and then I got the particular chunk of land and then I do the additive things and this and that and finally design the building. This is one way practice and now some of the schools in architecture in India, they started in the different practice what was actually formed in those days. They actually find out the center point of the mass, center point of the land and from there they evolve the circulation patterns and all and finally come down to a kind of a boundary where this boundary is negotiated with the present building bylaws boundary also. So that is another way of the teaching or the learning the building design or the Vastu design from the center to evolve, and what we are embedded in our brain from our first class of the architecture is that you take a site, you cut the site and periphery and then start putting the first part is the second part, maybe the back side is your all the rubbish things and all, then go up and all. Not from the center to the, like a flower, no, it is the something like a, so both are, can be read, can be judged, which is good, which is bad, and maybe some cases our thinking is good, in some of the cases maybe that one is good. So those are the, as I told you, those are the elaborate from the Kailash temple of the Ellora, which is the best example of this reverse engineering in the field of the structure sensitive case of Vastu, or maybe the Nirman kind of. This was the second. Let us go to the third arena. So these are the curved roof. Curved roof is also has a kind of a advantages instead of the flat roof. It has give you more opening size. In a same span, you require less amount of material to take care. So curved roof is always beneficial. It can be proven by mathematics also, how the curved roof is from the bending moment and all those point of view. The modern architecture also has some of the role to play. We have the metro railway projects below the Ganga in Calcutta. So that is one type of reverse engineering, but we have to intervene any kind of tunnel work in the in kind of, it is a kind of reverse engineering, but it is a very, I must say, with compared to the Ellora, compared to the Chaityas, it's crude form of that. So if there is something happened, I will just put plaster and all, look like very smooth. But it was not so in case of those Elloras and all. You have to make it smooth. So those are the different type of interventions was made in the Mauryan art. A coat of art or that was developed, and also some of the pottery and all other type of skill has been also developed. So Gupta period, this temple architecture was gradually formed. So that is also very interesting. So this is a Kankali Devi temple that is told to be, it was a early Gupta period, some kind of the structure, and this is the first form of the Indian temple that was as cited, which has only a the circular shell and the mandapa, only that. Gradually, if you see, it has raised, it has to be raised. Society wants the temple has to be raised because it is a place of God. So he has to, or she has to be in a higher in level. Okay, so if you go to in Bengal, in Jamindar's house, any Jamindar's house who ruled a particular land, maybe from 100 years or so, you see their house is also having a high plinth. They stand in a particular high level and dictate the people that do this, do that, don't touch this, don't do that, don't come to that. So that hierarchy in the society was actually shown by the height of the plinth, that I am in a higher level also. But here the temple has to be lifted up because the virtue of that is the highest, he actually guided us or whatever. So the second, another very important thing has been seen here is that there is a production or the ambulatory kind of a the path has been described in this particular temple. The next, if you see, the shikhara has been developed. So the difference between this and this is flat, this is flat. They started the shikhara development. Shikhara development is another way, one of the way that you can actually, height of the total structure can be increased, and that will be a kind of a signature, the building in your place or in your areas or so. So gradually it was, and whenever these gradual changes are formed, there is a challenge from the new material, there is challenge from the structure. How I am going to make the shikharas. So that was developed, that thinking, that process was developed. And that was very interesting. And then maybe the again the barrel kind of a longer, that one kind of the rectangular kind, how I can fit into the longer kind of a thing, that can be also thought of. And finally, this was the one of the temple which was this roof was afterwards erected. It was destroyed. The circle and how the dome, that was also their practice. Very difficult to actually make a dome by wooden, I mean stone kind of a features with a dome in a circular. So they practiced that, was the success in that way. So gradually you see the flat roof to the roof is now in a kind of a triangular, the pyramidical roof which is shikharas, and then they try with a barrel vault, and then they try with the how they can create the dome. So this kind of formation was seen in the period of Gupta period totally, and then it was these are the test bed, I must say. These are the not very prominent temple structure in India, but those are the test bed. They start testing and then gradually they come down to the next third one out of the four, the climate sensitive architecture construction. Sorry. Climate is, I should have actually put it first, because the climate was the first of our all concern. So initially, the prominent feature of the Indian architecture was the courtyard architecture, called as the Ekshala, Dishala, Trishala and the Chaushala. So Chaushala is the four quarters or the buildings which is internal a kind of a courtyard, which actually gives an incremental housing principle which is still there. I have a small family, I have a Ekshala, then gradually I have a bigger family, so I can convert that into a Chaushala kind of a thing. And as you all know, in a central courtyard kind of a structure is very prominent in our India today itself, particularly if the hot and humid climatic zone like Kerala, Bengal and all. Bengal it was almost evolved, I mean now people are not going into that, but still in Kerala there are lot of houses are there which is they follow this Chaushala kind of a character. If you see the Bengal, Assam and Bengal, this I have just now told in the very beginning, that mud housing. This material is one of the best material from the climate responsive point of view of this particular area. This has a, you need to have almost about 300 mm. 300 mm is almost like a 1 feet of thick, and it will give you a wonderful protection from the heat. It maintains a kind of a constant temperature inside. In summer also, winter also, it's kind of a same temperature. The only problem, see, I must say, all materials will have some kind of a problem. No material in the earth is having the problem free. Concrete has its own problem, steel is having own problem, the timber is also having the own problem. The unfortunate thing is that our engineers have not actually they always felt that mud is a very poor material and we cannot improve it. It's material for the poor people, it's material for the people who lived in the village and all, it's a material for the vernacular architecture, that let them do their own, but it has its own problem. The first problem is that in the mud building the percentage of opening is very less. Because of some reasons you cannot put, so the amount of windows are less. In this hot and humid kind of a climate, you require larger opening, but still it is less. That is why what we find in our studies is that in the mud buildings, they are very good in the night, but if the humidity is very high, this is going to be a little bit bothering, because the air exchange is not that much, number one. Number two, as the opening size is less, the daylight penetration inside the building is less. Number three, as this particular mud is kind of a material which always evolves some kind of a dust, inside air quality is also very poor. So these particular 3-4 things are definitely the drawbacks of the mud as a material, but no engineering studies have been actually addressed those, how to improve that one. That is the most unfortunate thing. So those, the external, the long part of the shading part and all these things also came as per the invention. So these are some of the mud house we can see. Even there are double storied mud houses also seen. If you just go to around 10 to 15, not 10, 15, 12 kilometers from our campus this side, you will see the lot of double storied mud houses also still there, and they are with a good character. Last week, a team from Hiroshima University came to IIT Kharagpur. We used to go and we used to study that one. They are very much excited to see. Even they told that in Japan also they have mud house, but they do not have the double story. They have a single story kind of mud house also. So this is very interesting. So we have not addressed properly this material. The second is if you go to the hilly areas of Himachal, again they do not have mud. So they use their local material. They use a local material like the slate or the stone as a material. So this particular also, if you see, these are the one of the areas in the Himachal where there is a very low temperature is very low. So thermal damping is very high from that point of view, and the thermal storage capacity is also very fantastic in case of the stone. It actually store a lot of, because it has a high thermal capacity, so it can store a lot of heat, and it can be used in case of the when night time also. But there are still some problem. The problem is, again, the opening is a problem we have not addressed yet. This particular machinery is very prone to collapse in time of earthquake, and the Himachal is one of the area where there is a huge amount of earthquake. Fortunately, after 1992 there was an earthquake in the Himachal, which is known as a Uttarkashi earthquake. In that there was lot of damage. After that, Government of India and some scientific research from the Roorkee IITs and all, that time it was not IIT Roorkee, they have initiated, and there are some thought, some kind of a things or some scientific interventions was there, retaining the stone as a stone. What slight change you can do that will help you in time of earthquake, that was made. But that was very, it's good to see that kind of a thing has been made, but not lot of research has been done. Go to Rajasthan. There is another set of examples of the climate responsive architecture. That is a hot and dry type of climate, not humid. So in that hot and dry, we do not require larger openings, because we do not allow the air to come in. So, but we need shading. We need some kind of, even if you see the particular, not the climate point of view, but the society point of view, they need some kind of a parda. Parda means there should be privacy. So privacy and the shading come to a infuse together and create a jali, that type of work, the jharokas and all, where anybody can sit with behind a jali, enjoy what is happening outside in a kind of a private manner, and also that jali will give a shading to him or her, and that will be protecting him or her from the direct solar gain, which is very, very tough or the tedious in those areas. There is a jali also. If you see in the Mughal times also, there are a lot of jalis that has been used and that was actually taken down to the Rajputanas and all. So those are the typical the character of the hot and dry climatic zone. And if you see this jali, one thing is that the jalis are very, very intricate and decorative. You see that we see picture, we take some kind of a selfie and all, background and all, because it is very decorative. See in this particular thing, it is the Mughal jali. It is very decorated. So that is one part of the thing, one part of the story. The second part of the story is that the jali was made by stone. The stone is having high thermal mass. So if the air passes through the stone, there is a contact of the stone and the hot air, there is a chance of, or there is a high chance of thermal interchange. Number two. So I want to have a higher amount of time to contact with the air to the stone, that I require, because then if the time duration of the contact duration between the passing air and the stone is increased, then the heat exchange also going to increase. So what will happen? The hot air will be little bit cooler, maybe 1 degree, 1.5 degree, some 0.75 degree cooler. That is very much from that point of view, cooling point of view. Now, to increase the surface area, increase the contact time, I have to increase the surface area. Then only, and if you increase the surface area, you have to make it decorated, make it kind of a decorated. Otherwise, how we can make it the surface area increment? You just make a small hole, the surface area is this much thickness. But if you can create some kind of a ups and downs and all those kind of thing, the surface area is increased. As and when the surface area is increase the flow of air will through that, the contact time is increased, and contact time in increase means the drop of temperature is going to increase because the stone will eat up lot of heat. So it's a match. You may say that it's very decorative and they did, yes, it is decorative, but the science behind the decorative part is that it is required for the cooling. And also, if you provide small amount, small amount instead of the large holes, small holes, and then your privacy will be remain. And as and when there is a small holes, there are a lot more surface area. So privacy and the science will be matched with that. So that is the way they have thought of, and that kind of that kind of mechanism. Now again, when you go through which type of stones, and it is a sandstone or maybe it is a kind of the marble stone, that has to be chosen from the material point of view. So those are the some of the, yes, this is the climate responsive housing of Kerala. If you go to the Kerala, entire different set of typology you will see. They have a maximum exposure in the north and south to reduce the heat gain. They want to capture the wind because this is very sweaty, because this is hot and humid kind of thing. So blows air through the air will give you some kind of relief because it is evaporative cooling. The opening are segregated opens and very segregated plan, not very much dense plan, large courtyard, those things are very much important. So if you see this particular building is your Chittor Palace, which is very near to Cochin. Very small, decent, cute looking palace of kings when they go and they sit over there also. See the veranda, see the top veranda, top part at the first floor veranda. You see the design of the window. Maximum opening has been kept. In the window, in wooden window, what you see, there is a hinge, and hinge will come and it will flush with a central stick. That is called mullion, the central stick, and the panel will come and directly put over there. Here that mullion is also vanished, the central piece is also vanished. The particular two leaf will come and all together it will going to join. So mullion will again provide some kind of a barrier to the wind. So if you can remove at least how many 10 mullions, there are much more amount of the airflow and much more visibility. In front of this particular window, which is in the this point, there is a huge lake. So there is ample amount of the evaporative cooling potential. You see the picture below. In this, the right hand side, there are some windows after this particular shaded long corridor, and that particular window is also having larger openings. I mean, opening in the sense very less amount of interference, so they allow the wind. So the ventilation is one of the major character in the in the architecture of the Kerala, which is placed to be the climate sensitive from the warm and humid point of view. Maharaja of Travancore has again constructed a palace called Padmanabhapuram Palace. It is around 50 kilometers down south from Trivandrum. And after maybe another 10 kilometers it is Tamil Nadu, and then it is your the last tip, that is Kanyakumari. So this particular wooden palace, it is a wooden palace, it is a worth to see this particular palace in Kerala, which is having different shells and different character. Architecturally marvelous, because if you see the actual palace, there are different reception hall, then the living quarters, then dining areas, kitchenette and all. But the most important part of the thing is that it's the best utilized the way a climate sensitive architecture could have been, it's erected in, and the material, most prominent material is the is the is the wood. So I don't have the photograph of that, but it is very much available of in anywhere in the internet. We used to visit this particular palace with our students in 2017. The last part of my lecture is the activity sensitive construction. So we talk about the material sensitive, we talk about the structure sensitive, we talk about the climate sensitive, then let us talk about the activity sensitive construction. The activity sensitive construction, let us first call about the in Jammu Kashmir, the Dhajji and Dhauri. See, this particular Dhajji Dhauri construction is a vernacular construction. No engineers has been intervening in that. Probably last 10 years or so after this particular, not 10, 20 years or so after this earthquake is become a very mega kind of event, we go and see the what is that. This particular type of construction, if you see, it is the wood and the stone mixed construction. The wall panels are made up by the diagonality of the wood, and those triangular open spaces is filled with the stones, larger stones and the smaller stones. This machinery is called Dhajji Dhauri, and this is the one of the best machinery has been seen to protect from the seismic activity. The thing is that when this the diagonals are made by the wood is one of the material which absorb lot of shock absorber. It acts as a shock absorber, and a diagonal pattern will actually behave a better shock absorber because diagonal pattern you have to give, because I do not know from which direction the earthquake will come. Earthquake may come, I mean, it's depend upon the where is the epicenter and where is all those. So it may come like this, it may come like this, or it may not be in the orthogonal direction of the building, it may come like this. So you need the multiple line of defense. So in a panel, a multiple line of defense may be created by at least by the diagonals or maybe further bifurcation of those diagonals. So this particular these diagonals, wooden diagonals will be the actual act as a shock absorber, and then it will be filled with the stones, and it is a dry machinery. So you may say that the dry machinery will be prone to collapse, right, which we have seen in the Himachal building. But it is a full, from bottom to top, it is full dry machinery. So if you shake it, it will going to collapse. But here what will going to happen, it is actually embedded or encircled by a triangular or some small pieces. So after kind of a shaking or after some kind of a vibration, first of all this dry machinery will rearrange itself. By virtue of the rearrange, some of the energy is absorbed. And even though it will be locally. It will be fail by virtue of this triangular part only. The triangular part of the failure will not lead to the failure of the next neighboring triangle. If next neighboring triangle has that much of scope and the orientation of the stones are in a different way, so it is not going to give you a progressive collapse. It may give you a local collapse. It may give you a small damages, definitely damages, but that damages will be arrested in a bounded by the wooden. How intelligently they have described this particular, constructed this particular building, which actually lead to some kind of the understanding of this particular thing is that how to stop the progressive collapse of the building in time of earthquake, which is very much essential nowadays. A multi-storied building may collapse. In Ahmedabad we have seen, in Bhuj you have seen a multi-storied building is been collapsed because of the damage of 3 or 4 pillars. And total building may have 40 pillars. Out of that 3 pillars, damage is actually devastating. It's a progressive collapse of the building. So what we have to learn from there? I do not know the solutions, but from this we should actually think of how to arrest the progressive collapse, and we actually manage the local collapse or by local damage. So I have written down the mortar machinery infills also that we have discussed. The next one is another part. If you see the Andaman and Nicobar Islands, the traditional houses of the Andaman Nicobar Islands. Andaman houses are conical and something like that. And the Nicobar Islands houses are something like this. Ongo. This is Car Nicobar house. Sorry. And this is the Onge house of the Andaman, little Andaman. Thatched, mud, bamboo. It is some wooden pillars. So very interesting. The number one is the shape of the building is either conical, circular, spherical, conical like that. These houses are little bit lifted. We do flood prone areas and all, we lift our house. Why circular? Circular is important because in time of cyclone, it is this particular area is prone to cyclone. Any cyclone you see it started in the, so cyclone, when there is a thrust of air, I mean when the air is blowing, if the air is blowing in a perfectly this kind of rectangular shape kind of a thing, it's actually give you the P into area, the area force, the intensity and into the area is full area, so intensity into area. But if there is a wind, the intensity comes, the area is only this strip area, other areas are tangential. So when the things will come, the effect of the force will be actually evaluated by virtue of the strip area and the intensity. So the other part, the wind will going to actually slip. So the total amount of thrust accumulated in a building will be much smaller with respect to a rectangular building or any kind of straight edge building. So we know this, we have some kind of a coefficient, I forget the coefficient for square housing, square building, that is the draft, I think draft coefficient or whatever, which is very high, this is very low, this is circular building is very less. So this, then that is why the cyclone shelters in Odisha, which is made now, we made it some circular kind of a edge instead of going with a perfect this kind of edge, making kind of a circular, that thing should be laminar, the flow should be laminar. But what those fluid mechanics, how they know the fluid mechanics so better in these particular buildings. In this particular buildings also, it is a very good noticeable thing is that you see the base is very large, the base of the building is very large, the height of the building is smaller. That means it is something like spreading the legs like this, and this is very stable. As and when you spread your legs and reduce your height, your center of gravity of the building will be very low. And as and when the center of building or gravity of the building is very low, it is very difficult to topple you. It is very easy to topple me because my center of gravity is here. I am a tall man. But a small and a hard built man, it is very difficult to topple because the center of gravity is low. So see the pattern of the building, circular and so this center of gravity, this fluid mechanics and all we know, but this is vernacular architecture where definitely there is failures in their lives also. When they construct, there are some failures, they watch the failures, they rebuild their house in a different way and finally come down to some kind of a conclusions. I think that's all from my side. I have addressed the 4 type of the construction type of technology activity. Any questions? Any questions or any discussion? Questions I may not able to answer anything, a lot of things, but I am very happy to discuss this. Yes.
They actually had to create an incline to get it up there. So how did that construction happen? If you are aware, if you could.
I do not aware of this, but this, please sit down. This kind of the lifting of the stone, heavy stone in a certain height. Suppose that is very interesting actually. Suppose this is an empty ground, and this particular heavy stone, which is actually will come like this and has to be placed at this particular point. So the coordinate of this particular stone is actually some height above. So you cannot without, so particularly after you build the walls, they usually do the ramping. the ramp made up by the sands and the earth fill ramp. So suppose this is the edge of the temple already, so I make a ramp like this, like this, like this, like this, and whenever I go top, the diameter of the ramp will go smaller because it is shikharas also. Like that, you have to travel this part and then you have to put the particular crown stone at the top. That was the practice. But whether that practice was, that was the practice in some of the buildings or the, particularly the gopurams of all the South Indian temples, which is huge, actually huge. So it's cannot be Chidambaram. So that cannot be erected, like they do not have the lift mechanism. So if the constructed, not the erected, constructed layer by layer. And lifting the stone has to be there. And you see it is beautiful. I mean, the scale of it, it's wonderful, these gopurams and all.
Pranam, sir.
Please sit down.
Thank you. I have just short 3 questions. First, what are the differences between Bengali architecture and Odissi architecture in the matter of temple? First one. And second one is I want to know about Nat Mandir. And third one is I want to. There are so many references in your PPT about Buddhist architecture, Chaitya, like this. Want to know something about this.
Okay. So I am not a very good Greek in this temple architecture. Professor Joyson is the best person, but still I can answer that. The Bengal gharana and the Orisian gharana are two different gharanas of the style of the temple. If you see the Orisian temple, it has 3 layers. It has a kind of the Garbhagriha, which is the final part. It is a Nat Mandir and it is a Bhog Mandir. These 3 distinguished part you will see in the Lingaraj temple, you will see in the Puri temple, and any kind of the well-built temple of the Orissa. The shikharas are also very predominant. Predominant means it is a cylindrical kind of a, not a pyramidical, cylindrical, and then it goes like that. The decorative features are also, and it is mostly it is the granite stone is being used. The Bengal architecture is, from that point of view, it is simple. It is based on the Charchala principles. It has, if you see the Bengal architecture, it is actually driven from the housing pattern of Bengal. Okay, so the style of that, just now we talked about the Gopuram. Actually the temple, the style of temple will be distinguished by the Shikhara, the development of the Shikharas and the top. If you see the Bengal Shikharas are Charchala or Dochala, if you go to the Vishnupur areas or so, you will see this, or maybe this kind of a hut kind of thing, the Charchalas and Dochalas temple. Temples are simple, has a pradakshina kind of a thing, and do not have the elaborate features of the Nat and all those. There are some features, of course, there are some temples which has this Nat Mandir and all. So Nat Mandir is the second layer where usually some of the activities are going on. Some dance activities, some singing activities associated with the temple is going on. This is also a part where there was, if there is maybe a certain particular time, Rash, Purnima and all those kind of a time, when there is a huge gathering, you can actually accommodate that gathering by virtue of that the Nat Mandir also. So that Nat Mandir part is very faint or very missing in the Bengal architecture. Bengal architecture is the Garbhagriha, Pradakshina kind of a thing, cylindrical or maybe the squarish in shape, and there is a kind of a Charchala or Atchala, Charchala or Dochala kind of a roof. The third question is your Chaitya. Chaitya is a Buddhist, prominently Buddhist prayer hall where there are the Buddha and the God and there is a prayer gathering space. Mostly it is very, very deep rectangular kind of a geometrical forms, very high in the altitude in that sense, because here also very interestingly one acoustical phenomena comes into the picture, which is called the reverberation time. If you have a large area, and the large area with a very high amount of reflective material will give you a kind of a reverberate. This kind of reverberation will generate. So Chaityas are that kind of a character, and this is the prayer hall for the Buddhist. I do not know. I am sorry. I have that part. It was probably you know better than me if you can relate that one in the which eras or so. I am not so.
Any insights on the
sit down.
any insights on the terracotta temples of Vishnu Ghose?
Yeah, terracotta. You must visit today or not today. I mean, after this particular FDP, once in terracotta. Terracotta temples of it's called the Mallabhumi. This part, and this part, the temples of terracotta are. I mean, it was actually good to see. The terracottas are in the actually act as a cladding material. Cladding material means it is a fascia materials. You see, it is a block, either a square block or maybe a rectangle or maybe a circular, but circle cannot be a block. They have made strips of conical kind of strips, arranged in a such a way, and this has also a good material technology. It doesn't provide any kind of thermal insulation, no, but it is a very wonderful decorative material, and it depicted some story line. It's Mahabharata story or Ramayana story or some local story that was depicted by the features of the terracotta. It's burned soil or the clay. If you have time, please visit. It will take maybe one day. Going from here to Bishnupur, it will be 2.5 hours. You stay there for another 3 hours and come back.
First of all, sir, thank you for your very practical presentation for me, because I am from non-engineering, non-science, and the non-Sanskrit background. But I just want to know, in our villages we can found that houses that are made of bamboo branches and mud. In native language, we call it as soling houses. So, will you tell me about something about this house?
See, these houses are practiced because these two materials are very easily available in the village areas. In our Bengal, are you your Bengal? So it's very richly available, and it is available. They usually take the mud from the near to the pond or something, and they create that one, and they mixed with some kind of a stabilizer, and they put one by one. Sometimes in this, what I told about, around 12 kilometers away, they do not have any bamboo, they have only the mud wall. They put it in the 3-4 layers. Bamboo is also good. Bamboo give you some kind of a reinforcement in case of it is going to bind you. But the only thing is that if you go to the I do not know about these Midnapur areas or so, in case of the cyclone, roof is a problem of bamboo house. Roof is a problem. Roof sometimes it is damaged. Number 2, in time of flood. So bamboo, the problem is sorry, not bamboo. Bamboo bamboo mud type of construction is that in time of flood, the plinth area, that particular area is actually going to be affected by virtue of the water and all. And you need every year you need to have some kind of plastering. So we are thinking of if I can give you some different type of plastering. Those plastering was what we talk about, little bit of cementarious plastering will provide some kind of a better. We have seen some of the areas in Jharkhand. I was, before I joining in IIT KGP, I was in BIT Mesra. I was faculty over there. So I have also visited a lot of areas of Jharkhand. They use cow dung also, cow dung and the mud and some kind of the local, the laterite kind of, not laterite, some kind of a stone dust, and they put the plaster in the mud house, and over that they decorate with some kind of painting, local painting also, very nice looking, but practically that will going to block the some kind of the wind and surge, wind water surge in time of rainy season also. But this particular material, the bamboo, as you told, bamboo strips and the mud, this particular material behaving very poorly in Sundarban area, because this area is prone to flood or prone to cyclone every year. I have told to visit, I have not visited, but there is a NGO is working with us. This is very pathetic. So that is why I told you, we engineers are not intervene the problem of those people. We always thought of, architects are always thought of the people who are actually the, architecture actually is a profession of urban areas. But I feel there is lot of problems still lying in those areas. Sundarban areas where there is a the cyclone and the intense rainfall frequency is very high, this material has a real problem. So we need to see, we are thinking of, in Bangladesh also this is the same scenario. If you, I have visited Bangladesh and I have, in a disaster management conference, I have also interacted with a lot of people over there. What they do is they tell them to construct the till the sill level, that means this part, this window sill level part, by virtue of brick, and over that bamboo, chatai, mud, anything. So alternative something has to be there, because you have to understand that bamboo and mud is very good, very low energy material, but it has some problem also in time of water seepage and all those. Yes. In policy, in the sense, what I can say, this stone house, even stone mud and normal kind of a machinery housing, for that may not be the policy, but the engineering guideline to make the houses seismic proof is already there. But otherwise flood and all, we do not know. I mean, we are still now thinking of doing it something like that. But definitely the seismic was not done by us. It was done by the IIT Kanpur, IIT Roorkee, but that was a compiled document, and we follow that document whenever we intervene some of the areas for stone machinery house, mud house, and any normal the brick machinery, non-engineered brick machinery. The guidelines for seismic safety is already there. But policy wise, it is not that much framed that you have to do this, you have to do this. Yes. Yes.
So that means, so there were archaeologists, so they confirmed that up to 4,000 tons of stone must have been excavated. So the duration is estimated by them at around 18 to 20 years. So they did further calculation. So they say So if you would have cut out around 60 tons of stone a day, that would it mean, right? 60 tons of stone per day. So that would mean 5 tons of stone were removed per hour. So this is an achievement that can hardly be attained even with our state of art today.
Right.
So then questions arise. How can it be? Is it possible? I mean, they had just hammers and stones. Maybe, but maybe also not. Maybe the technology was much faster, much further developed those days. And even so, my question is, what do you say? I mean, is architecture also thinking of how dare some even say to take the step and ask the help of a superior species from space as a builder, right? In view of the Vedic, I mean, this is about Vedic also here. That's why I thought it might be interesting. In view of the Vedic scriptures that have been conveyed down to us, they used the Be Lively interstellar communication. So there are really questions I'm asking you, since you're for so many years in this field of architecture, how such monuments have been constructed with archaic tools, and why the perfect orientation to the west, orientation of the temples in India towards the sun is nothing unusual. However, orientation to the east is preferred. All these questions I'm very much curious about.
Okay. So you talked about this 5 tons per hour. See, it's 5 ton per hour. That doesn't mean that I will do today 5 ton and per hour and then next hour 5 ton. If you see the temple, if you take a bird's eye view from the top and see the temple, there is a lot of open space, and there are some interim spaces, which is the Kailash temple also. So there are 2 or 3 type of manpower which was involved. As I understand from some of the literature, the construction process literature of this particular temple, still I am very much finding, I didn't know, but I told you that maybe they are somewhere, but I know there are somewhere, but I still not yet to chance to read. But there are three types of people or the manpower which they are involved, and this particular stone, suppose if you take this particular maybe if you see this particular part, it is full empty. So the human resources which they are asked to do the cut this particular rock piece and take it out. May not be cut totally, so the slicing, take it out. It may not take that much of time because it doesn't require that much of accuracy and all that. So this particular part will be lifted out, and as and when you part lifted out, maybe in this particular day you may lift out maybe 200 tons of things. So majority of the total excavation was done maybe within the 6 or 7 or 8 years out of the 20 years or whatever the largest span. So whenever you dig, and definitely it is something, today also we do our metro railway projects, how many times we change the plan because of some intervention, something like this and that. Similarly, after the whole excavation has been done, probably they now thought of that what should be the different approach routes and what are the different shells and whatever. So it is then the second layer of the architecture came into the play, When the second part of the people who are not that much strong in build, but they are very much good in the carvings and all, they are employed in the particular as a manpower and they do the finishing kind of a work also. So I feel is that it is the two different ball game altogether. First 6 to 7 years total excavation, creating a kind of a local kind of a map, and then gradually go inbuilt into the finer decorative part or whatever. Yes, sir, you are. Please sit down.
Wall thickness is about 2 feet, 1.5 to 2 feet. The building was still there. The building was constructed during my study. This collapsed around 5-6 years ago. So, are we compromising on the
Quality, yes.
Cutting the cost?
We are compromising with the quality, we are cutting the cost, we are compromising with everything. See, it is very good question because in 2011 I have joined, 2013 to 2016, 3 years, I was the vice chairman of our construction division of IIT Kharagpur. So we have interacted with lot of this contractor for lot of building construction and all. Unfortunately, everybody is looking for this kind of tiles nowadays. We forget about the red oxide flooring, the typical type of the terrazzo flooring. Okay, those were there in the old IIT buildings, old laboratories and all. But nowadays we forget, we do not have. We intentionally want to do some of our labs with the terrazzo flooring, but the contractor told, sir, don't rely on the today's labor, they cannot finish it. They cannot maintain the proper, so they are now habituated with this kind of vitrified tiles and this. So it is construction time is also one of the very important thing. Probably in your school, I am sorry to hear that a particular building which was constructed maybe 40 years back or maybe 30 years back is now no more because of the low type of construction. It is compromising with the construction time and the maybe definitely. The wall is standing. It is compromising with that. This material, cementitious material also has a kind of a role to play. It sometimes, you know, that started some kind of the local chemical reacted with the bricks and all, and then that particular portion is going to damage also.
There are old buildings more than 200 years.
That will going to stand.
They are constructed of stone. The mixture is tuna and
Lime.
wood.
Yes, good. Yes, good, and you know the bell fruit. The juice of the bell fruit mixed with the tuna and mixed with your gur is one of the very sound material for the thermal comfort and for the mortar. So those things are now, if you say, there is a things called lime terracing which we have to put in the rooftop because make the things waterproof, the roof waterproof, chhad, jal chhad, we called in our Bengali language jal chhad. So it required almost 150 mm, that means 6 inch thick. Those materials, gur, then bell ka juice and tuna with surki. Surki is the dust of brick, surki. Okay, dust of brick, tuna, bell ka and the gur, bell ka juice and this 4 with a 3 layer, tamadam, पीट के 5-6 दिन में वो बनाता था. आजकल एक दिन में कर देता है with the asphalt, काला asphalt लगा देता था, वो हो गया. So that is the change. We need things very quickly, we do not know what is the reaction of the asphalt, that is the coal tar, काला जो tar. What will be the reaction of the coal tar with the concrete just below that? We do not experiment that one, we do not know anything that, but that may create a problem. That may create a problem. The coal tar, the kala kala asphalt sheet, that and the below the concrete, is these two different chemical materials. They may have a problem. They may not be a very good friend, and that effect we will find out after 10 years, 15 years or so. So that is the biggest problem. Which things are predominantly stay for longer duration, like lime terracing, as you told, which vanish nowadays. And we engineers are very sorry to say that, I blame myself also, we are not actually no experts available and no knowledge actually taken out from that and written in the textbook. Ratios and all those kind of a thing. There are now, it is the high time, there are few people knows. If that generation goes, vanish, we will be lost. It is like a Shruti like thing. There is no documentation writing, it is a Shruti. Sunke, that is the vernacular architecture. Sunke, forefathers. So if that generation gone, we are gone.
Can we take one quick last question?
That is a camouflage, definitely. Otherwise, camouflage means it's a kind of, the magic kind of a thing you see, but there is science behind. But there are definitely maybe a central something is there which is going to be taking care of the load. So it is not that structure dimension got down. It may be a kind of a stone which is very light in weight and maybe float in the water or whatever kind of a thing. Which temple is that? Huh? Hampi? Hampi? Yeah, Hampi. Andhra Pradesh. I must visit that one. Sorry, I do not have any answer to that.
So with this, we will conclude Professor Shankar Pratim's session.